Solve the following system. Determine if the critical point 0, 0 is stable, asymptotically stable, or unstable. Determine whether 0, 0 is a node, a saddle point, center, or spiral point. dx over dt is this, dy over dt is this, or they can give us in terms of this matrix form. So x prime y prime equal to 0 minus 1, 4, 0, x, y. So we use eigenvalues methods, find eigenvalues, eigenvectors, values. So lambda is an eigenvalues, a minus lambda I. Compute the determinant of 0. In our case, minus lambda minus 1, 4 minus lambda. Determinants lambda square plus 4, 0. Lambda square equal to minus 4 or 2i square. Lambda is plus or negative 2i's. In this case, we know it's lambda pure imaginary. So we know this must give us elliptical orbit. Ellipse. X1 is ellipse, so centers at the origins. So the origins 0, 0, the critical point is a center, stable, but not asymptotically stable. Remember that asymptotically stable. So we already answered one of the question. Origin is a center and it's a stable. If we want to show that, so let's show it. Lambda equal to this. Try to find the eigenvectors. So big lambda 2i. Lambda equal to 2i. So as we know, we need to find AB so that this one is 0, 0. A trick with 2 by 2 matrix is that we just keep one rows. Let me keep the second rows. 4A, 2IB, 0, 2A, IB, 0. We'll choose A equal to I and B equal to 2. Yeah, so that would give us 2I minus I, 2 equals 0. So that is 1 eigenvectors. And the one corresponds to minus 2I, just a conjugate of that. So we don't need to worry about that. This is V. Now this gives us the eigenfunction that goes ft V E lambda t. V is I2 E minus E2IT. I2, we use the Euler formula. Recall that E I theta cosine theta I sine theta cosine 2t I sine 2t. This one is I square minus sine 2t I cosine 2t and 2 times cosine 2t 2 sine 2t. The real part gives us one first function, second part gives us the other one. Combination of the two gives us the general solution. X, y, xt, yt equal to c1 times this plus c2 times this, c1, c2 are real. And in case you want to write more, just this one equal to minus C1 sine 2t, C2 cosine 2t, 2C1 cosine 2t, C2 times 2 sine 2t. Yeah, this is the general solution. C1, C2 are chosen arbitrarily, real numbers. Solution, it could be ellipse. This is origin. The other one, ellipse should look, let's say this ellipse. We have ellipse or Poisson ellipse rotates about this origin. So now we need to determine whether it's go clockwise or counterclockwise. Just pick, say, the point 1, 0. Matrix A. This is matrix. Multiplies on 0 gives us the first columns. 0, 4. 0, 4 is parallel to this. So it's better to have the ellipse like that. So that's at that point it's parallel to 0, 4. So the points go up. 0, 4 here. So it's rotates counterclockwise on this ellipse, and with that we can draw a few other ellipses. And so counterclockwise. The origin is a center and it is stable.